Hi friends, today we are going to discuss about the chemical properties of benzene diazonium salts. So here benzene's diazonium chloride I have taken, which is C6H5N2 plus Cl minus, and that is preparing from C6H5NH2, which is aniline. So we can convert aniline to benzene diazonium salt by a process which is called a diazotization reaction. And for that we use a reagent NaNO2 and HCl. So aniline on reaction with NaNO2 and HCl under a particular temperature like 0 degrees Celsius, we can change it into diazonium salt. And this is the process which is called a diazotization. And the product, benzene diazonium salt, is having a lot of practical application. From this we can prepare a number of compounds like chlorobenzene, bromobenzene, iodobenzene, cyanobenzene. So many compounds we can prepare industrially from benzene diazonium chloride. So today we are going to discuss about all those conversions by using a very quick mind map. And these are the conversions which I am going to discuss, like aniline to chlorobenzene, bromobenzene, iodobenzene, cyanobenzene, fluorobenzene, nitrobenzene, benzene, phenol, and some isobenzene. So let's start with those conversions. So the basic reaction is, first you have to convert aniline to benzene diazonium chloride, and from there only we can prepare all these compounds. So let's see a mind map for that. So for that, first I have written the reaction, the diazotization again I have written, and in the center we can see benzene diazonium chloride, and from there we will start doing the conversions. So I'll start from the left side. We need to add Cu2Cl2, cuprous chloride, and HCl. If you are adding this reagent, you get C6H5Cl, that is chlorobenzene. When you add Cu2Br2, cuprous bromide, and HBr, we get C6H5Br, that is bromobenzene. These two reactions are called a Sandmeyer's reaction. Sandmeyer's reaction is coming in our lesson haloalkanes and haloarenes. When you add Ki, potassium iodide, we get C6H5I, iodobenzene. Instead of potassium iodide, if you are adding CuCN, cuprous cyanide, and HCN, hydrogen cyanide, then it will be changing into C6H5CN, cyanobenzene. Now, next reaction is we add copper powder and HCl, and then we get C6H5Cl, chlorobenzene again. It means for chlorobenzene, two methods are there. One more reaction, we add copper powder along with the HBr, so that we get C6H5Br, bromobenzene. Again from bromobenzene, there is a second method. And these two reactions where we are using copper powder is called a Gattermann reaction. Gattermann reaction. There is Gattermann-Koch reaction which is there in aldehydes lesson, that's different. This is Gattermann reaction for chloro or bromobenzene by using copper powder and HCl or HBr accordingly. But if you use Cu2Cl2 or Cu2Br2, then the name of the reaction changes to Sandmeyer's reaction. Okay, next when we add HbF4, which is fluoroboric acid, we get C6H5F, that is fluorobenzene. One more reaction, when you add fluoroboric acid followed by NaNO2 addition, sodium nitrite, in presence of copper powder and heating, then we get, instead of fluorobenzene, C6H5NO2, that is nitrobenzene. So fluorobenzene and nitrobenzene from aniline. Then when you add water and then warm the reactants, then we get phenol, benzene with the OH. So that is aniline to phenol. First aniline to diazonium salt and then to phenol. Again C2H5OH, ethanol if you are adding, you will be getting C6H6, benzene itself. Instead of ethanol, if you are adding H3PO2, then also you will be getting the same product only, that is C6H6, benzene. So for benzene, there are two methods, by adding ethanol or by adding H3PO2. Next two reactions are similar, which is either we can add C6H5NH2 to diazonium salt, means aniline to diazonium salt, or we can add C6H5OH, phenol to the diazonium salt. These two reactions are called a coupling reaction. So in this mind map itself, there are three named reactions: Sandwich reaction, Gattermann reaction, and now coupling reaction. Coupling reaction in detail I'll explain. We start with the benzene diazonium salt. For that I am drawing the benzene ring to understand the reaction. Benzene diazonium salt is having N2 plus Cl minus, and that N2 is having N triple bond N2 plus Cl minus. This is a vertex which is on reaction with aniline C6H5NH2. And during the reaction, in aniline, the para position carbon, there is a hydrogen. That hydrogen eliminates with this chlorine as HCl, minus HCl under the arrow mark. So that the triple bond, nitrogen triple bond is here. One of the pi bond is shifting here. So that a bond is formed between this nitrogen and the next benzene. So you'll be getting the first benzene, and as triple bond change to double bond, we write N, double bond N. After that, a single bond, which is a newly bond, which is formed by from the transfer of a triple bond to a double single bond, and then the benzene ring, and in the para position NH2. So this is a product. Here this product is having N double bond, and this group is called a azo group. So these groups are forming, or these groups are important in dye preparation or colored compounds, and this dye is yellow in color, yellow colored dye, and which is also called a para amino. Why? Because NH2 group is there in the para position. Para amino azobenzene. That's the name of this product. So we prepare aniline to para amino azobenzene by adding diazonium salt. The same way, instead of this, when you take this same diazonium salt and when you add phenol, instead of aniline, when you add phenol, the same kind of reaction takes place. Only the product difference is after N double bond N, benzene, and then the last para position is replaced by OH, which is also called a para hydroxyazobenzene. The pattern of reaction is same only. And this is also a dye only, and that dye is in orange color, which is an orange colored dye. These two reactions are called a coupling reaction. Okay, so I'll just fill this also here. If you are using phenol, we'll be getting C6H5 and double bond N, then C6H5 you don't write, it's H4 because one hydrogen left, then OH. Similarly here, C6H5 N double bond N, C6H4 NH2. This is para amino azobenzene and this is para hydroxy azobenzene. So these are the important compounds. So everywhere you start writing aniline first. First you convert aniline to diazonium salt and then you to prepare all these different compounds. So these are the different techniques to prepare different types of compounds from diazonium salt. So this diazonium salt is having very good practical application. So I have discussed all these conversions. So in your textbook, there are some questions in your exercise which is related to this type of questions. So you go through the textbook and practice all those. Thank you.